Good morning. Moving ahead, today's topic is how to calculate gradients in PyTorch, and PyTorch requires to calculate gradients very frequently. So there is this library called autograd which is used to calculate the gradients, and the gradients are, while training, the gradients are calculated mostly with respect to the model parameter. The model parameters are W and B. So you know from the theory of deep learning that uh, deep learning is all about adjusting and modifying the weights W and B such that the model converges and the loss is minimized. So for that we have to train the model and modify the weights again and again, and for that we need to calculate gradients. So let's have a look at this diagram. I have taken this diagram from pytorch.org, and here we are going to realize a simple neural network model which will have this form, a simple neuron which will have this form: z is equal to wx plus b. So this is x, which is input, w is the weights, so this is multiplication sign, so this creates w into x. This is plus, and this b is for biases, so this whole thing is wx plus b, which is equal to z, which is the prediction of our network. And this prediction of our network is compared with the actual class label by this loss function CE. CE stands for cross entropy. So cross entropy will take the prediction of the network and the actual class label as input, and it will calculate the loss. And then in back propagation, that loss, the derivative of loss will be calculated, and then that will be back propagated to modify the weights. So yeah, this is basically what we are going to realize and try to demonstrate the working of autograd. So yes, it's a simple neural network, and the equation is wx plus b, and w and b are the parameters that we want to optimize. I told you already that C stands for cross entropy, and loss is calculated at the end. There is a property of a tensor called grad underscore fn, which gives the gradient function of a tensor. And there is another property called as requires grad. When this property is set to true, gradients are calculated, and when this property is set to false, then gradient calculation is disabled. So in some situations we have to calculate gradients, and in some situations we have to disable the calculation of gradient, which will become clear eventually in the same tutorial. So moving ahead with the code, we want to take some values for x, y, w and b. So let's take a tensor of ones with 5 values for x, a tensor of zeros with 3 values for y, and then w we are going to initialize randomly, whose dimensions are 5 by 3, and we want to calculate the gradients. For w we want to calculate the derivative of loss function with respect to w, and that is why required gradients is made equal to true. B is bias, so we have chosen them randomly with 3 values, and required gradients are again equal to true, because we want to calculate the derivative of loss function with respect to bias as a part of back propagation. And ultimately the equation is realized using this. So this is matmul. We have learned this in one of our previous tutorials. matrix multiplication of x and w, so it is wx plus b is equal to z. That's how we realize our equation. And then to calculate the loss in torch, in neural network package, in functional, there is this loss binary cross entropy with logits. It takes the network output z and the actual class label y to calculate the loss. So this will calculate the loss for us. So far we are at loss calculation. Then next step is, once we have got the loss, we calculate the derivative of that loss function with respect to w and b to optimize them. And derivatives are calculated with this function loss dot backward. If you give this function, the derivatives are calculated. So loss dot backward will calculate the derivative and the gradients. If you want to check the gradients, you just have to print w dot grad b dot grad and you will get the derivatives. So these are the output. This is the output for w and this is the output for b. So these are the gradients of weight and biases. That is how it is done. Then we know in deep learning that the network goes through a forward pass and backward pass for one epoch, for every batch actually, and the gradients are calculated during the training, because that is the time when we want to optimize the weights and biases. But once the training is over, if you want to test your model, or if you want to give an input to get an output, at that time gradient calculation is not required, because we are no more interested in optimizing the parameters, for parameters have already been optimized during the training. So gradient calculation should be disabled while testing or while giving an input to the model. So in such case the gradient calculation is disabled as shown in this code. So again, just to demonstrate, we are giving this equation z is equal to wx plus b, and now check if the gradient calculation is enabled or not. So z dot require gradient will return true or false. If the gradient calculation is enabled, it will return true. If the gradient calculation is disabled, it will return false. So here I am expecting that it will return true, because by default it is true. And if you want to disable it, then one way is using this with torch dot no grad. So for the tensor, here no gradients will be calculated. So during this calculation, z is equal to torch this, gradients will not be calculated. So if you again check whether the gradients are enabled or not, at this point it should give a false. So for the first print statement should give true and the second statement should give false. So here the gradient calculation is enabled, but with torch dot no grad the gradient calculations are disabled. That is why it is giving us false. Another way of doing the same thing is by using a detach method. So yeah, so again I take this z is equal to wx plus b, and here it should display true, because initially the gradient calculation is enabled. But when you give z dot detach and assign it to another variable z det, then for this new variable, if you check whether the gradient calculation is enabled or not, it should give false, because the gradient calculation is disabled by this z dot detach function. So if you run it, for the first print statement it gives true, for the second print statement it gives false. So this detach function has disabled the calculation of gradient. So the important point to remember and understand from this particular tutorial is we need to calculate gradients when we are doing the training, but we don't need gradients when we are doing testing. So during testing we have to disable the gradients. There are two ways to disable the gradients. Either you use this no grad, torch.nograd, or you use detach, or even you can give require gradient equal to false. That will also disable the gradient calculation. If you have understood this, then we are ready to go and optimize our parameters, and we will do that in our next tutorial. Thank you so much. Thank you.